Hi class, this is the lesson for Monday, February 13th, Introduction to Combinatorics Part 2, and we'll also look at the factorial notation. So what we've already learned is the fundamental counting principle. This is also called the multiplicative counting principle. So we looked at that in some depth. We said whenever we see and, we tend to multiply. Right, this was referring to if there's multiple stages with a different number of choices for each stage, we can multiply them together to get the total number of possibilities. What I also mentioned in class was whenever we see the word or, we're tending to add our number of choices together. So we're just going to formalize that a little bit now. So you should all have this note. The rule of sum or the additive counting principle. So some problems cannot be used using only the multiplicative counting principle. For example, this one. So suppose the passcodes for garage door openers can either be 2 letters followed by 2 numbers, or, so there's our keyword, 3 letters followed by 1 number. How many passcodes are possible if repetition is allowed? So we can have the same letters over and over again or the same digits. It doesn't matter. So we have 2 cases basically. 2 letters followed by 2 numbers, or 3 letters followed by 1 number. So how we're going to use our additive counting principle is find the number of possibilities for this situation, find the number of possibilities for this situation, and add them together. Okay, and this is what is shown here. So this is for our garage door code with 2 letters followed by 2 numbers. So this is for the first letter, the second letter, the first number, the second number. There's 26 choices for that first letter because there's 26 letters in the alphabet. Same with the second letter because we can't have repetition, so still 26 choices. There's 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10 digits for our choices for the last number as well. Multiplying those together because that's one situation. Okay? Then we're going to add that to the number of possibilities for our second situation, which is 1, 2, 3 letters, followed by 1 number. And these are the number of choices for each of those. Okay, so just multiplying those together separately and adding them together. Here's another example. When drawing a single card from a deck of cards, how many ways can a king or an ace be drawn? Okay, so there are 4 kings and a standard deck of 52 cards. So there's 4 choices for our first card. And we're going to add that to the number of choices we can draw an ace because we said or. So there's 4 aces and add those together is 8. And that's what's shown here as well. Okay. What about the number of ways we can draw a red ace or a diamond? Okay, so the number of choices for a red ace is 2 because we can have the ace of hearts or the ace of diamonds. The number of choices for drawing a diamond is 13. We know there's 13 cards of each suit in a deck of cards, so there's 13 diamonds. Now something tricky is going on here. We're subtracting 1. That is because there's 1 card that satisfies both of these conditions, right? The ace of diamonds. So we don't want to account for that twice, right? If we just left it without the -1, we're actually counting that card here and here. We don't want to count it twice, we want to count it once, so we subtract that 1 choice. And we're left with 14. Right, and that's what it says here. We already counted the ace of diamonds twice, so we want to subtract off 1 to account for that. Here's another question. When drawing 2 cards from a deck, how many ways can you draw a king followed by an ace? So we're drawing a king and an ace. Okay? There's an and implied there because we're doing both. So the number of choices for drawing a king is 4. There's 4 kings in the deck. The number of choices for drawing an ace is 4 because there's 4 aces in the deck. We said and, we're drawing both of those, so we're multiplying. Next example, how many ways can you roll a sum of 7 or 8 with a pair of dice? So you can look at this set of ordered pairs here. So this would be rolling a 1 and a 1, rolling a 1 and a 2, or rolling a 2 and a 1, etc. These are all the possibilities for drawing or for rolling two die or two dice. So it's or. So we're going to find the number of choices for having a sum of 7, the number of choices for having a sum of 8, and add those together. So if you go ahead and look at all the sums for these two dice, we see this row is all going to add to 7. And these ones add to 8. So there's 6 choices for the number of ways to add to 7. There's 5 for the number of ways to add to 8. So we are going to add those together, meaning we have 11 ways of rolling a sum of 7 or 8. This last question we already did in class, so you guys should be experts on that. If you need some extra clarification, be sure to ask in class. Now taking a look at factorial notation. Something a little different. So many counting problem calculations involve the product of a series of consecutive numbers. You can use the factorial notation to write such expressions more easily. So what consecutive means is one after the other. For example, the numbers 1, 2, 3 would be consecutive numbers, or the numbers 5, 4, 3, they're consecutive. They're one after the other. Here they're increasing, here they're decreasing, but they're both consecutive. So for example, how many 5-digit numbers can be formed using the digits 1, 2, 3, 4, and 5 if repetition is not allowed? Okay, so we have to have different digits for each space in the number. Okay, so it's a 5-digit number, so we have digit 1, we have digit 2, digit 3, digit 4, and 5. We're going to see what are our number of choices for each, and we're going to multiply those together. Okay, so for digit 1, we have 5 choices because we can use the 1, the 2, the 3, the 4, or the 5. So 5 choices. For digit 2, repetition cannot be allowed, so whatever we chose for digit 1, we can't choose anymore. And there's only 4 choices left. Similarly, for digit 3, we can't choose the digits we used for the first 2, so we only have 3 choices left. Then continuing the pattern, 2 choices left for digit 4, 1 left for digit 5. Okay, so if we multiply those all together, we have 120 different 5-digit numbers that can be formed from the digits 1 through 5 if repetition is not allowed. Okay, whenever we see something like this, a number multiplied by 1 less, by 1 less, by 1 less, by 1 less, until you get to 1, we can express that using something called factorial notation. Okay, so we can actually represent this as 5 factorial. That means take the number, which is right before the exclamation mark. In math class, we call that a factorial. Write down that number, multiply it by 1 less, 1 less, 1 less, 1 less, 1 less, until you get to 1, and then stop. So 3 factorial would be write down that number, multiply it by 1 less, until we get to 1, so then we can stop. So that will equal 3 times 2 is 6, times 1 is 6. 8 factorial, same thing, we're going to write down the number, keep multiplying it by 1 less, 1 less, 1 less, until we get to 1. times 4 times 3 times 2 times 1. Okay, so if you multiply that all together, that would be equal to 8 factorial. There should be a button on your calculators as well. Sometimes you might have to do the second function, but it will just look like an exclamation point. So you can put factorials in your calculator. You'll press the number, so 8. On my calculator, I have to do 8, second function, and wherever the factorial button is. And then it will do this calculation for me. This question says, write 5 factorial in 3 different ways. So we know 5 factorial is 5 times 4 times 3 times 2 times 1. That's one way to write it. We could also write 5 times 4 factorial, because isn't that the same thing? That would be 5 times 4 times 3 times 2 times 1. We end up with the same. Similarly, we could do 5 times 4 times 3 factorial. Those are all the same expression as 5 factorial. Write n factorial in 3 different ways. N factorial in 3 different ways. Well, we could write n times n minus 1 factorial. That's the same thing, because when we do n factorial, we're going to take n times 1 less than n times 1 less times 1 less times 1 less until we get to 1. So that's the same as multiplying it by 1 less, the factorial of 1 less, right? Just like we did up here. So we could also write it like this: n times n minus 1 times n minus 2 factorial. That's fine. Or n times n minus 1 times n minus 2 times n minus 3 factorial. Those all mean the same thing. So we can use factorials, our knowledge of factorial notation, to solve some problems like this. So evaluate the following. 80 factorial divided by 79 factorial. If you put a large number factorial in your calculator might just give you an error because the number is so large. Think about it. This is 80 times 79 times 78 all the way down to times 1. That's a really big number. Instead, we can simplify this. So 80 factorial is the same as 80 times 79 factorial. Hopefully you agree. Divide by 79 factorial. Now we can actually divide these out, and we're just left with 80. So it's just a little trick. Similarly here, 75 factorial divided by 73 factorial divided by 3 factorial. Let's express that 75 factorial in a way that includes 73 factorial. So 75 factorial is the same as 75 times 74 times 73 factorial. And then we're still dividing by 73 factorial times 3 factorial. We can multiply or divide those 73 factorials out. That's why I expressed this like this, so I could divide those out. Then I'm left with 75 times 74 divided by, well, 3 factorial is 3 times 2 times 1. We can easily put this in our calculators and solve the problem. Hopefully you see a pattern here. 200 factorial divided by 198 factorial. We can express that top one in a way that includes 198 factorial. This is the same as 200 times 199, always 1 less, times 1 less, and we can just write a factorial. So that we can divide those out, and we're just left with 200 times 199, which is something we can definitely put in our calculators. Again, if we put something so big, factorial, in our calculator, we might just get an error. Over here, simplify the following. Don't let these variables get in your way of solving questions like this. It's still the same pattern. We can rewrite anything factorial a different way as long as we're following the rule. We're multiplying by 1 less, 1 less, 1 less, 1 less. Okay, So I want to express this top so that includes this bottom so I can divide it out. So n plus 1 factorial is the same as n plus 1 times 1 less. So n plus 1 minus 1 would just be n. N plus 1 minus 1 would be n. And then we can multiply that by 1 less, which is n minus 1. And we can just write a factorial. Okay? Now we can divide this out. And we're just left with n plus 1 times n. That's going to equal n times n is n squared. 1 times n is n. And we could just leave it like this. Okay? Here's another one. N squared plus 3n plus 2 times n factorial. It can be a little tricky to see what to do here. You'll notice this is a trinomial. So let's start changing the way this expression looks by factoring this trinomial. So we need two numbers that multiply to 2 and add to 3. That would be 2 and 1. So this factors to n plus 1 times n plus 2. And then we still have that multiplied by n factorial. Okay, try and expand this out. You will get this expression. Okay. So now, can we see any patterns? The way I've written it makes it a little difficult, but let's look at it like this. What if we rearrange it n plus 2 times n plus 1 times n factorial? The reason I did that is because now it's in an order where this is 1 less than this, right? N plus 1 minus 1 is n, and n plus 1 is equal to this, n plus 2. What I'm trying to say is they're in consecutive decreasing order. Okay? So that would mean that this is the same as n plus 2 factorial, right? Because multiplying it by 1 less, multiplying by 1 less, and then adding the factorial so that it goes all the way to multiplying by 1. Okay? So give those practice problems a shot and see how you do. Bring any questions to class. I will be back on Thursday if you want to ask me, or you can ask your supply teacher or your peers for help, and we'll get those figured out. Thanks, guys.